you're bound to run into an absolute apex predator of a tool called Orca. But here's the thing. Depending on exactly who you ask, its definition wildly differs. We're basically looking at a tech multiverse here. We've got 5 completely distinct, highly specialized tools that all happen to share the exact same name. So what exactly is Orca? Is it a massive cloud security platform? A huge breakthrough in AI research? Maybe a desktop screen reader? A 3D printing utility? Or a digital audio sequencer? Well, surprisingly, the answer is all of the above. To make sense of this, we're going to map out the taxonomy of these 4 distinct tech habitats: cloud security and DevSecOps, teaching small AI models, GOM desktop accessibility, and fabrication and audio tools. Now let's dive right into cloud security and DevSecOps. At the enterprise software layer, securing your development pipeline is quite literally priority number 1. We all know integrating security early, what we call shifting left, is notoriously difficult. Using traditional manual command line tools requires frustrating coordination and, inevitably, it just bogs down development operations. Enter the Orca GitHub app. This tool eliminates that friction entirely by providing seamless, automated repository scanning, letting admins onboard entire organizations practically overnight. This automated integration establishes an immediate code baseline. It's constantly scanning your application source code and infrastructure as code for any vulnerabilities, misconfigurations, or exposed secrets. But crucially, it enforces a strict separation of duties. Your security teams can centrally manage policy, while your DevOps teams get immediate, actionable insights, without actually having to operate the security tools themselves. In practice, this acts as an incredibly smart, automated gatekeeper. Let's say a developer submits a pull request that accidentally introduces a vulnerability with a known public exploit older than 15 days. Boom, the policy instantly kicks in. The pull request is totally blocked until it's resolved, essentially treating a security failure exactly like a failed automated unit or performance test. Next up, teaching small AI models. Moving far away from enterprise cloud security, we enter the AI research lab, where Microsoft's Orca 2 model is fundamentally rewriting how smaller language models learn to reason. We all know large language models are highly capable, but they are also incredibly massive. So to teach smaller models to reason effectively, researchers are using a breakthrough technique called prompt erasing. Instead of holding the AI's hand with detailed step-by-step instructions during training, researchers strip all of that away, replacing it with a generic prompt. By completely removing the blueprint, the student AI is forced to internalize the complex reasoning process itself. And this progressive training yields some truly remarkable logical deduction. Take a classic logic puzzle. John puts a ball in a box and leaves, then Mark moves it to a basket. Where does John think the ball is? The Orca 2 reasoning trace systematically maps out a 5-step timeline, perfectly isolating what John saw versus what Mark saw. It navigates the logic completely autonomously, easily outperforming models that rely on simple assumed continuity. This deep internal reasoning makes the model incredibly adaptable. It can parse super dense factual information, like pulling specific voltage specs from a massive block of battery documentation, and then instantly switch gears to evaluating logical consistency. For example, by weighing the destructive nature of floods against the agricultural benefits of rain, it flawlessly deduces why one sentence makes logical sense and another doesn't. It is honestly a masterclass in varied reasoning strategies for a small footprint model. Moving on to habitat number 3, GNOME desktop accessibility. In the open source community, the Orca namesake tackles something absolutely critical: human-computer interaction. Within Linux and Solaris desktop environments, GNOME Orca serves a vital mission. As a completely free, highly flexible screen reader, it empowers visually impaired users by translating the graphical interface into customizable streams of synthesized speech and refreshable braille displays. It is an indispensable bridge for real digital accessibility. Under the hood, this requires a deeply orchestrated technology stack. It relies heavily on ATSPI infrastructure to interface directly with the operating system. From there, it uses specialized Python bindings to communicate with physical braille displays and route text-to-speech dispatchers. It even integrates awesome tools like MathCat to audibly parse complex mathematical markup on the web. It's just a beautifully engineered system running silently in the background. Finally, fabrication and audio tools. Down in the makerspace, The Orca moniker drives two highly specialized tools used for physical fabrication and audio programming.
First up is Orca Slicer, a heavily optimized 3D printing utility. This rapid production workflow is a game changer. You drop a model in, it auto-orients it for structural integrity, and lets you apply advanced preparation, things like painting multicolor layers, hiding Z-seams, or even applying localized fuzzy skin textures. After you micro-adjust your layer heights and ironing surfaces, the model is sliced directly into precise machine code.
Sharing this same creative space is a unique tool for sequencing digital music, which is also called Orca. This esoteric text-based visual environment interfaces directly with the host system's audio architecture. It connects seamlessly through multiple virtual ports, like Timidity, to sequence and fire off complex MIDI data to external synthesizers and drum machines. So, through this explainer, we've navigated a wild multiverse of apex predator technologies. From shifting enterprise security left to forcing small AI models to internalize complex logic. From ensuring open-source desktop accessibility to sequencing live digital audio. They all share a name, but they dominate completely different habitats. In a tech landscape that grows more complex by the day, the real question isn't just what these tools do, it's which part of the Orca ecosystem do you need to deploy to become the apex predator in your own workflow.